Part A. Expand 3 plus 2x to the power 4 in ascending powers of x, giving each coefficient as an integer. So we'll start off with 4c0, 3 to the power 4, 2x to the power 0. Then 4c1, 3 to the power 3, 2x to the power 1. Then 4c2, 3 squared, 2x to the power 2. 4c3, 3 to the power 1, 2x cubed. And then finally 4c4, 3 to the power 0, 2x to the power 4. Let's simplify each of those terms now then. So 4c0 is 1. 3 to the power 4 is 81. 2x to the power 0 is 1. 4c1 is 4. 3 cubed is 27. 2x to the power 1 is 2x. 4c2 is 6. 3 to the power 3 squared is 9. 2x all squared is 4x squared. 4c3 is 4. 3 to the power 1 is 3. 2x cubed is 8x cubed. 4c4 is 1. 3 to the power 0 is 1. 2x to the power 4. 2 to the power 4 is 16. And then we have an x to the power 4. Simplifying each of those terms then, we'll have 81. Then 4 times 27 times 2 is 216x. Then we have the 6 times 9 times 4 is 216x squared. The 4 times 3 times 8 is 96x cubed plus 16x to the power 4. So that's my answer for part A. Part B. Hence, or otherwise, write down the expansion of 3 minus 2x to the power 4 in ascending powers of x. Well, it says hence, so this should have something to do with what I've just done. And if we compare them, actually this is exactly the same as what I've just done. The only difference is it's a minus 2x instead of a positive 2x. So rather than starting from scratch, let's see if I can just go back to part A and think about what would happen if it was a minus 2x instead of a positive 2x. So this first term, this would be a minus there now. This would be a minus here. This is a minus here. This is a minus here. And this is a minus here. The first term wouldn't be affected at all because minus 2x to the power 0 is still going to be 1. So my first term is still going to be exactly the same. It's still going to be 81. My second term, minus 2x to the power 1, well, that's going to be a minus 2x there now, and therefore I would have a minus 216x. The third term, I've got a minus x, a minus 2x squared. Now, when I square that minus 2x, it's still going to be a positive 4x squared. So actually this next term is not affected at all. The third term, minus 2x cubed, would actually now give me a minus 8x cubed. The minus 2 times minus 2 times minus 2 would make a minus 8. So I'd have a minus 96x cubed. And then finally the fourth term here, the minus 2x to the power 4, well again, that's going to be a positive. The power 4 will make that positive, so that's not going to be affected at all. So that's my answer for part B. Part C, hence, choosing a suitable value for x, show that 3 plus 2 root 2 to the power 4 plus 3 minus 2 root 2 to the power 4 is an integer, and state its value. Okay, it says hence. So what's this got to do with what I've just done? Well, notice we've got the power 4s, so they match up. We've got a 3 plus here. We've got a 3 minus here. So this is basically, this is the same as what I did in part A. Just compared that to what I did in part A. That's the same, but just with x being root 2. If I took my answer from part A and put a root 2 here instead of the x, then it matches up. And similarly, for this here, if I took my answer from part B, and again, put root 2 here instead of the x, then this matches up. And then I can just add my two answers together. So basically, if I just add my answer from A and B together, it will give me all of this, and then I just make x equal to root 2. So let's do that. Let's add my answer from A and B together. So 81 plus 81 is 162. The 216x minus 216x cancels out. The 216x squared plus 216x squared will be 432x squared. The 96x cubed minus 96x cubed will cancel out. And the 16x to the power 4 plus 16x to the power 4 is 32x to the power 4. So this is an expression for 3 plus 2x to the power 4 plus 3 minus 2x to the power 4. If I now actually make x equal to root 2, so it matches up with what I needed to find, so it'll be 162 plus 432 times root 2 squared plus 32 times root 2 to the power 4. And if I work that out, I'll get 154.